Start recording. Looks like we have about 10:31. Let's say hello to everyone. It looks like we have Jaden, Kendall, Tyler, and Vero here so far. I have a really cool announcement for you guys. And if you'd like to turn on your webcams, that would be awesome. You don't have to. Make sure you have your chat open if you don't turn on your webcam. But you guys have the distinct pleasure, I guess, of being videotaped right now. So this is awesome. You are going to be part of a commercial. So it's really kind of cool. Yeah, Jaden, do you have a comment? No? All right. Yeah, you're going to be part of a commercial for our school because you guys are the most awesome class that I have. So I chose you guys. All right. All right, we're excited. Off camera, yeah. Okay, we're excited. I can tell. So yeah, if you feel comfortable, go ahead and turn on your webcam. But today, I just wanted to go over our agenda and let you know what we are going to be covering. First things first, though, we need to talk about our enduring understanding and our goals for today. That enduring understanding that we use for book clubs, humans use strategies to construct meaning, also applies in our math class as well. We use different strategies to make meaning of these different math concepts. And our goals of communicating, collaborating, thinking critically, and using creativity also apply. So, for instance, when we communicate, we're sharing our thoughts, questions, and ideas about the math concept, not necessarily about the theme of our novel, but when we're communicating and collaborating, we're all sharing those ideas together. So, thinking critically, we do this a lot when we talk about how we use math in real life. That's a critical thinking skill. And then also, a lot of times, the way that we solve problems is different. So, thinking about another way to look at something that your students, your peers present is also a cool thing. All right, so we'll not spend too much more time on that. Let's go down to what we're going to be getting into today. We're going to be talking about graphs, and then we're going to get into a little bit of practice around mean, median, and mode. And of course, we have our games that we'll be playing and some practice time. But I know I've been going kind of fast. I'm not usually videotaped, so I'll slow down for a second. Let's just talk about, we'll go back to those examples of real life where we see math. When we're thinking about graphs, I think about large sets of data. So I think about numbers, large sets of numbers, and how confusing it can be if they're not organized in a nice fashion. So then I think about, well, where do I see large sets of numbers that I need to put into a graph and have it be organized? And here are a couple of my examples. I think about the grades that I take for you guys all the time. What would happen if I didn't write down your names and maybe I just kind of scribbled down 74%, 33%, and I just kind of did it in a sloppy fashion? What might happen to all of that data? And your microphones are on, so you can raise your hand or just pipe up. Go ahead, Tyler.
It'll be harder to understand.
Yeah, it'd be harder to understand. How would you feel if I wrote down 33% as your score when I had gotten it mixed up because I had made a sloppy mess of my data, but really you had gotten a 95% on your test? Kendall saying she would not feel good about that.
No, I wouldn't.
No, exactly. So that's like the purpose
I
of
would.
why we make those different types of graphs. I'm thinking about going to Las Vegas soon. Um, I need to know what the temperature is going to be like. What if nobody kept track of those temperatures in a nice graph format? What if I had just no clue how I should dress in Las Vegas? Well, that's another example of where we use graphs. What about sports teams and all of their scores? If I'm trying to keep track of one sports team, if I start mixing it up with everybody else, especially I think about baseball when they play like 500 games or whatever, that would be pretty confusing. So, those are examples of math that in real life that apply to today. Can anybody else give me an example of? Okay, go ahead, Jaden. It looks like you want to say something. Do you have an example of large sets of numbers that maybe a graph would help with?
Uh, um, uh, uh, 80 with a line graph.
Yeah, well, that's a really good type of graph. I'm thinking of a line graph, and that's charting those temperatures again. A lot of times you can see that happening. What about if I'm tracking your progress? I would probably use a line graph for that. Maybe you would start kind of at the bottom, and then your line would start
And
shooting.
then a bar graph.
Yeah, that's great. All right, well, we have a short little video that's going to show you a few more examples of when graphs are necessary and then different types of graphs.
And
So,
a pictograph.
yes, that is definitely another type of graph. All right, hopefully I'm still logged in. I am, yay. Okay.
Cruising around the Caribbean in search of adventure. This sure is the life, isn't it, Moby? Whoa, what's this? Welcome, travelers. We have learned that you are searching for the monster of youth. Follow these clues and eternal childhood will be yours. The monster of youth? Never heard of it. But, well, okay, let's do it. For your first task, you must find your way to the Caribbean nation with the most ducats. Ducats? Oh, money. Well, this sounds like a job for my trusty world fact book. You can find anything in here. Let's see. Caribbean countries with the coolest flags. Caribbean countries with the most spectacular shipwrecks. Here it is. Caribbean countries with the highest gross domestic product. Oh, that's a measure of how much money a country has. But, this list of numbers is all garbled and confusing. Maybe we could use a graph to help us visualize which one has the most, ducats. Well, I'm thinking we can use a bar graph. First, we list all the independent countries of the Caribbean along the bottom, or x-axis, and on the left-hand y-axis, we mark off levels of, ducatage. We can use the graph to compare values of money per person for each country. Looks like we're headed to the Bahamas. I wonder what we do now. I really want to find this monster of youth. Well done. For your next clue, you must find the Bahamian island with the largest area compared with the area of all the Bahamas combined. Godspeed. Okay, who's sending us these things, and how can they see us? Well, let's go back to my fact book. I have a listing here of the biggest islands of the Bahamas, sorted by area. I think we should use another graph to help us see it more clearly. Since we're graphing pieces of a whole, let's use a circle graph, or pie graph. Right, the island of Abaco has 1,680 square kilometers, Acklands and the Crooked Islands have 520 square kilometers, Andros has 5,960, and so on. Andros Island has the largest slice, so I guess it's the island with the largest area. Off to Andros, my good man, robot. I don't see any birds. Wonder if we made a wrong turn. Okay, just an octopus, nothing to see here. You have proved yourselves worthy seafarers. For your final task, you must disembark and find the nest of the fabled Bahamian Chickcharnies. Once there, you will encounter the legendary monster of youth, Cheerio. What the heck is a Chickcharnie, and where are we going to find one? Yeah, me too. I'm starting to wonder whether these Chickcharnies exist at all. I mean, I'm all for finding the monster of youth, but what's the point if it's going to take us forever? Let me double check my fact book to see if they even exist. Well, according to this line graph, the number of Chickcharnie sightings has decreased steadily over the last 300 years. Yeah, see, the number of sightings is plotted against the scale of years from earliest to latest. You know, Moby, they could be extinct. What was that? What could it be? It's so funny looking. Hello. We're looking for the monster of youth.
I am the monster of youth. But I'm afraid you're too late. My powers of granting eternal youth are all used up.
All right, guys. All right, so that was a fun little video that showed us a couple different types of graphs. What type of graphs did you see in that video? Go ahead, Jaden.
Bar, line, and pie graph.
Good, so it showed us at least 3 different types. Let's see if we can find a few more. All right, we have one of our, it's gonna be live. There we go. We have one of our little interactive lessons. So this one is going to teach us something for just a second, and then we have to participate. So a little bit more on different types of graphs. Here we go. This is about displaying data. And that's what I was talking about earlier, that there are different ways to display data, large sets of numbers, and different graphs are better for different types of data. All right, here we go.
At this county fair, you pay one price for admission, and then you can go on all the rides as many times as you want.
We conducted a survey of people attending the fair to find out how many rides each person went on in one day.
Each person told us the number of rides they went on, and we put each number into one list.
It doesn't mean much when it's all in one big list. We need to organize this information in a way that makes it easy to understand.
Let's look at...
Okay, so let's just take an opinion poll here. What type of graph would you maybe think would be good for this type of data? This is the number of rides that the kids went on in one day. What type of graph do you picture? Go ahead, Jaden.
I'm picturing pie graph.
A pie graph? Okay. Or maybe a bar graph? We'll see what they say.
Some examples of how data can be displayed. Then we can come back to our data. Here's an example of data that needs to be organized. A science test has a total of 10 possible marks. These are the scores of the students in the class who wrote the test. The scores are listed in no particular order. A good way to organize this kind of data is to use a frequency diagram. What we really need to know is the number of times, or with what frequency, a particular score appears in the list of test results. Notice that we display the scores in this column starting with the lowest score from the list, and ending with the highest score from the list. Although there were 10 questions on the test, no one scored 1, 2, or 3, so there is no data for these numbers. We fill in the numbers between 4 and 10. We use each number only once on the chart, regardless of how many times it appears in the list. Now we can record the number of times each score appears in the list. We will place one tally on the chart for each time the number occurs in the list. Click once on each score of 4 in the list of scores to record the tallies on the chart. When you've recorded a tally for each 4, click on the check button.
Okay, so how many times do we see 4? Looks
I
like
have 2 answers. So 4, 10. So 4 and 1.
Yep, 4 is once. Good.
Click once on each score of 5 in the list of scores to record the tallies on the chart. When you've recorded a tally for each 5, click on the check button.
How many are there, Jaden?
2.
Perfect. Cool.
Click once on each score of 6 in the list of scores to record the tallies on the chart. When you have recorded a tally for each 6, click on the check button.
4.
Perfect. Oh, did I miss one? I might have missed one. There we go. Sorry, it was 5.
When you are making tallies, remember to group them in 5. 4 tallies with the 5th going diagonally through the others. We'll fill in the rest of the chart for you. The last step is to write the number of tallies for each score in the frequency column on the chart. This tells us how many times each score appears in the list of scores. How many times did the score of 4 appear in the list of scores?
Okay, so go ahead
Count the tallies for 4 and enter this number in the space provided, then click on the check button.
Good. You caught on right away. Hold up your fingers or type it into the chat. Perfect.
How many times did the score of 5 appear in the list of scores? Count the tallies for 5 and enter this number in the space provided, then click on the check button. How many times did the score of 6 appear in the list of scores?
Good job.
Count the tallies for 6 and enter this number in the space. How many times did the score of 7 appear in the list of scores? Count the tallies for 7 and enter this number in the space provided, then click on the check button.
You guys are fast.
How many times did the score of 8 appear in the list of scores?
Woo!
Count the tallies. How many times did the score of 9 appear in the list of scores? Count the How many times did the score of 10 appear in the list of scores?
All right.
We have completed the frequency diagram for this set of data.
Let's try displaying the same data in another way.
Okay, so line plots. Here we go.
We can display the same set of data in a line plot. We'll use this same range of numbers for the possible scores, but this time they'll appear as a number line. And instead of the tallies we used in the frequency diagram, we add one X for each time a particular number appears on the list of scores, like this. This line plot is another way of displaying the science test data.
Now we have the science test data displayed 2 ways, in a
And I'm going to stop right there for a second and just tell you that in a couple minutes when we start finding the mean, median, and mode, line plots is a really easy graph to look at when you're doing that, and we'll look at a couple of those examples. Where's the play?
frequency diagram and in a line plot. Based on the data displayed in these diagrams, what is the total number of students who wrote the test? Enter your answer in the space provided, then click on the check button.
Okay, total number of students. There's 2 ways to find that answer. You can add up all of the numbers in this column, or you can count the number of X's. Go ahead and type it into the chat once you've done that. Good, Jaden. Awesome. So most people are typing in that there are 20 kids total, and that's correct.
Based on the data displayed in these diagrams, what was the highest score received on the test? Enter your answer in the space provided, then click on the check button.
Okay, so what was the highest score? It looks like the scores were, you could either get a 1 on the test or you could get a 10 on the test as the highest. So it looks like one kid got 10 out of 10 correct. So that would be the highest score you could have received. Good.
Based on the data displayed in these diagrams, what score was received by the greatest number of students? Enter your answer in the space provided, then click on the check button.
Okay, so most students received a score of 7. Perfect, Jaden and Kendall, great. And you can see that they had the most X's there, and then of course the most tallies. Good.
By displaying the science test data on these 2 types of diagrams, we were able to analyze it more easily than if it were displayed in a list.
That sounds good. No problem. All right. That was fun, huh?
Let's look at another example of data that needs to be organized. This movie rental store surveyed people who entered the store one evening to determine which age group rented the most movies. This will help them decide what kind of movies they need to have in the store. The ages of the customers are shown in this list. First, we'll set up our frequency diagram. We need to determine the range of numbers to be included in the ages column. Click on the smallest number in the list of ages.
All right, guys. So why don't you type into the chat the youngest person, I guess. What would be the youngest age that you see? That's right, 14. Perfect. Okay.
Click on the largest number in the list of ages.
All right. Who is the oldest person in this list? That's right, 68. Okay, good.
If we were to complete this column with all of the numbers between 14 and 68, we would have a really big frequency diagram. It makes more sense to group the numbers in intervals. An interval is a set of numbers between two fixed numbers. Our first interval can include all ages from 10 to 19. Complete the ages column on the chart by clicking and dragging the intervals to the correct places.
Okay, I'm just
Then click on the check button. You will not use all of these intervals. Look at the ages to see which intervals you need.
Oh, I might not need all of them, so I need to slow down a little bit. Okay, do I need to have anybody between 20 and 29? Yeah, I do, because there's somebody who's 20. Okay. Do I need to have, sorry, let me get it up there.
May I help?
Of course.
Well, you may need one of 60 and 39. 30 to 39.
Yes, that's right. Because there is nobody who, oh, well, wait, let's see. 20 and 39. Let's see. Is there anybody who is in, there's 33. Let's leave it like that for now and see what else we might need. 50 and 59. Yeah, there's somebody who's 54, so we definitely need that one. Looks like we need this one as well. Because there's a 68-year-old and a 60-year-old.
That's a 69. Oh.
Drag each age from the list to the correct spot on the chart in the tallies column. Be sure to drag every number.
Okay, so let's do this one person by person. So Vero, tell me which numbers to drag into the 10 to 19 chart or column.
14.
Okay.
15.
Okay.
18.
Okay. Oh, shoot, sorry.
You
were right. It's just not dragging very easily. There we go. And 16. Yep.
And 17.
And 17.
And 19.
And where'd that 19 go? There it is. Okay. Perfect. All right, Jaden, tell me what to drag into this box.
Another 18.
Is there another 18? Oh, we missed it. Sorry.
Yeah. 20.
Yep.
25.
That's right.
26.
I think that might be it for that column. Yeah. Tyler, tell me what to drag into the 30 through 39.
32.
Yep.
33.
Yep.
And
that's it. All right, and then Kendall, tell me what to drag into the 40 through 49.
40.
Yep.
49.
Perfect, and those are the only two for that one. And then back to Vero, tell me what to drag into 50 through 59.
58.
Okay, I just grabbed
58.
54. I'm sorry. Yep, 58. And 58. And one more.
And 59.
Perfect. And then, of course, The last one is pretty easy. We'll put it in there.
What?
So I hope you guys are seeing that there are different ways to display data, and some charts are better than others for different types of data.
The frequency diagram is now complete. Let's make a line plot using this same data, then we can use both charts to help us analyze the data. We're going to transfer the information from this frequency diagram onto a line plot. The first step is to make the number line using the intervals. Click and drag each interval from the frequency diagram to the correct position on the number line.
Okay, I'll just help you out. Obviously, you want to start on the left-hand side with the lowest. So we want to make it, the smallest to the biggest. That just should make sense to you, I hope.
Can you just put 60 and 69? Never mind.
There we go.
Drag the frequency number from the frequency diagram onto the line plot above the corresponding interval.
Okay, watch. So they're going to turn it into little X's. See how easy that is to see visually now?
3, 2, 4, 4.
Yeah, I know. It's not dragging very easily for whatever reason, but I'll get there. So visually, which one of these two graphs is easier to look at if I had to visually do this?
I think one X's.
Yeah, the one with the X's is easier to compare, I would say. I'm going to take a picture of this so I can come back to that particular line plot in just a few minutes. Okay, so I'll come back to that picture. We'll use it here in a minute.
Now we have displayed the data in two ways. Which age group rented movies with the greatest frequency? Click on the circle next to your answer of choice.
Very easy to see. This age group has the most number of X's, so they rented the most.
How many people in the 10 to 19 age group rented movies? Enter your answer in the space provided, then click on the check button.
Okay, how many people in the 10 to 19 group? Yep, go ahead and hold up your fingers. 7. Perfect. Good.
By analyzing the data, the movie store owner can make decisions about which types of movies to keep in stock.
Now let's look at one more way to display data, and then we'll go back to our county fair data.
Okay. All right, a different type of graph.
We have looked at displaying data using a frequency diagram and a line plot. Another type of diagram is a broken line graph. A broken line graph is used to show a change over time. For example, the maximum daily temperatures in Red Deer were recorded each Monday for 10 weeks in the spring. The collected data looks like this.
Ooh, that's not very easy.
We used a grid for a broken line graph. The dates go along the horizontal axis. We'll label this axis date.
That's
the
much
temperatures
easier.
will go along the vertical axis. Since they range from 4 degrees to 24 degrees, we can divide the axis into intervals of 2 degrees, like this. And we'll label this axis temperature in degrees Celsius. We can now plot the temperatures for the corresponding dates. The maximum temperature on March 4th was 4 degrees, so we plot the point at 4. Use the data in the list to plot the temperatures for the dates by dragging the points to their correct positions on the grid.
Okay.
When all of the points have been plotted, click on the check button.
I'm going to stop there for now so that we have time to do some of this other fun stuff like finding mean, median, and mode. So I'm going to go to that picture that I just took, and we're going to talk a little bit about mean, median, and mode. Have you come across that yet in any of your lessons? No? That's okay, because this is a great preview of things that are about to come. So when you get to it, you're going to be little wizards, and it's going to be awesome. So we're going to be looking at this little X plot here on the bottom, okay? Or line plot, I should call it. And when I'm talking about the mode, that is the number that shows up the most. So it's the most frequent number. So which one of these categories is the mode?
10 through 19.
Yeah. So there we go. There, that one is it's just simple and nothing to really talk about much more. Hold on, I'm just going to wipe this clean. Couple other pieces of vocabulary that you need to know, and that is called. Let's go with. Let's start with range. And range is the highest number of your data minus the lowest number. So let's look at our highest age. So our highest age is 69. Okay? What is our lowest age that showed up? It was, and actually it's not shown here, but I know it was 14. So the range between the highest and the lowest, go ahead and work that problem out. What would be my range? 69 minus 14. Perfect, Vera. The range is 55. Good. Awesome. Now, there's another number. Let me wipe this clean again because it's going to get too messy. Called median. Median is the middle value. And here's a really simple way. When you are working with line plots, it's really simple to find. To find the median means middle. Let me just write that. You're going to start by marking off x's until you end up with only one x left. So let's mark off the highest number and then the lowest number. And then you mark off the highest and the lowest. You keep going, highest, lowest, highest, lowest. Okay, keep going, highest, lowest. Just watch for now, highest, lowest, highest number, lowest number. So I'm going to keep going until I end up in the middle with one number left. Okay. So my median ended up with, and there's only one choice here. So this would be my median range. It would be this particular set of data, the 30 to 39. So I ended up in the middle. All right, let's go, and I'm not going to do the mean yet until we do just a little more practice. Okay. Mean is the average. So what I would do to find the mean is I'm going to add all of them up, and then I'm going to divide by the total number. Just keep that in mind, and I'll show you an example here in a second. The median is the middle value, like I just showed you, and the mode is really simple to find. It's the number that appears the most. Okay, so I don't like that data. I'm going to make my own data. Okay, so I'm going to wipe this clean. Give me just a second, and I'm going to draw kind of my own data and my own line plot. Oh, let's see how straight I can make this. Not very. All right, let's just, let's work simple at first. Let's go from like 1 to 10. 2, 3. Just give me just a second. Let's say that this was a quiz and you had 10 possible points. And let's say that we had, okay, maybe 20 students. Okay, so along the bottom, oh, that's really ugly. Gosh, sorry, are my scores. You could have a 1 on the test and you did really bad because you got 1 out of 10 correct, or you could have 10 out of 10 correct. And I have 20 students. I'm going to say that one kid blew it. 2 kids did not do very well. So this is 3 students. I'm going all the way up to 20 students. I'm going to say a lot of kids did really well, though. So that's 4 students, 5 students, 6, 7 students, 8 students, 9 students, 10 students. A lot of kids got 9 out of 10 correct, so that's good too. 1, 2, 3, 4, 5, 6, 7. All right, so that's 10. Here's 11 students, 12, 13 students, 14, 15, 16, 17, 18, 19, 20. Okay. All right, so I'm done with my data. Let me explain what I'm showing you here. So once again, you have a quiz that had 10 points possible, and there were 20 kids who took it. The kids are represented by the X's, so there should be 20 X's total. One kid blew the test, and he only got 1 out of 10 correct, and then a lot of kids either got 10 out of 10 correct or 9 out of 10 correct. Let's find something simple first. Let's find the mode. Which number appears the most? Did more kids get 9 out of 10 correct, or did more kids get 10 out of 10 correct?
Mine, I'm saying 10. 10.
So let's count. 1, 2, 3, 4, 5, 6, 7. 7 kids got 10 out of 10. 1, 2, 3, 4, 5, 6, 7. Oh, can they both be the mode? Yes, they can.
Equal.
So the mode is 9 and 10 because most kids got 9 or 10 correct. Okay, give me a thumbs up if that makes sense so far. That one's pretty easy.
Yup.
Okay. Let's find another easy thing called the range. The range is the highest minus the lowest. So the highest score is 10. The lowest score was 1. So 10 minus 1 equals 9. That's very simple. Okay, so now let's find the median. I showed you this just a couple minutes ago, but I'm going to show it to you again, how to find the median. I mark off the highest and then the lowest. And then I'm just going to keep doing that until I end up in the middle.
I don't think you can.
Okay.
I already have the answer. 9.
Yes, that's right. The median is 9. Because I could sit here and mark off the highest and the lowest of 9 if I want to, but I'm still going to end up with, what did I end up with? 9.
9.
My score. Okay, give me a thumbs up if that made sense so far. All right, what we need to find now is slightly harder, not really, but it's called the mean. What you're going to do is add up all of the values and then divide by the total number of students. So here we go. We're going to have to kind of make a long list. 1 plus 2 plus 2. Notice one student got a score of 1. 2 students got a score of 2. That's why I wrote that. Plus, how many kids got a score of 7? Just 1. Okay. Plus, how many kids got a score of 8?
2.
So I'm going to add that twice. So go ahead and write this down with me. How many kids got a score of 9? 1, 2, 3, 4, 5, 6, 7. Okay, instead of writing 9 plus 9 plus 9 plus 9, what's 9 times 7?
63.
Perfect. How about we just make that easier on ourselves instead of writing 9 7 times? How many kids got a score of 10? 1, 2, 3, 4, 5, 6, 7. What's 7 times 10?
70.
Cool. I could write 10 7 times if you prefer, but okay, so let's add these up. I'm going to give you a minute. That's your first step, is to add up all of the values. Go ahead and do that now. You probably had to put them in a horizontal fashion.
Okay, well, I got like 1, 2, 2, 7. That's 12.
Well, when you added up 63 plus 70 plus 8 plus 8 plus 7 plus 2 plus 2 plus 1, I will just help you out a little bit just so that we go. Perfect, Tyler got it. When you add all of these up, you get 161. Your next step is to divide by the number of students who took the test. So 161 divided by 20. It doesn't come out quite even, and a lot of times averages don't, and that's fine. This is the average score. So this is like most kids got this score or something close to this score.
Don't you remember one kid blew it?
Yes, exactly. And you know what he is called? He's called an outlier. He's dragging our average down. Just kind of doing this with you. So most kids got about a score of 8, but we noticed by our data that more kids had a score of 9 or 10. When that one kid got the score of 1 and those 2 kids got the score of 2, they dragged our average way down because those 3 kids are something called outliers. They made our score, they made this number lower than it really should have been. But yeah, I mean, it's the same thing though. That is how you would find the average or mean of the data. Okay, so we've covered a lot today. I think I'll save the game for next time, but you have this this little agenda that I sent to you, and I have linked all of these fun things, and you can go back and watch anything that you'd like to rewatch or do some practice problems with graphs. And then, of course, we'll work more with mean, median, and mode in the future. But that was just a short little introduction for you. How did that go? Pretty good? Thumbs up? Good. I think the only one that sometimes confuses people is the average or mean. The other ones are really actually pretty easy to find, the other scores, when you're talking about mean, median, and mode. Okay. All right, guys. So there is no virtual classroom on Monday of next week. I will see you on Thursday of next week for a book club, and then the following week will be normal. Okay? So you guys have a fantastic weekend. Wave goodbye. And by the way, you did fantastic. This commercial that we're making for our school is going to be awesome. So
is the video taken still recording?
No, he left actually. He left right about that time. Well, right in the middle of that second video I was showing, he left. But you guys did great. All right. Wave goodbye.
Bye.
Bye. Happy weekend. Yay.
Bye.
Bye.